For this tutorial, I decided to work on non-photorealistic rendering. The first effect I implemented was cell shading, which created this effect. This was achieved by using a one-dimensional texture to define the light level at each point. The texture had 4 levels ranging from white to dark grey, and used a calculation of light intensity at each point as a texture coordinate. The light intensity was calculated by taking the normal of each point in I-coordinates and the distance of each point from the light and performing a dot product on the two vectors that you came up with. I'm fairly happy with the result, although it could do with some smoothing around the change between shading levels. The next effect I implemented was edge detection, which I did in 2 ways. The first way I tried was the Sobel filter edge, which gives a result like this. This worked by comparing the brightness of adjacent pixels on a rendered image, and if there's a large change in brightness, then it detects an edge. As you can see, it gives an edge, especially around the outside, but it's not brilliant, and it does leave artifacts, especially along the changes in intensity of the light. So I tried a different method which works directly on the 3D mesh rather than an image produced by it, and this gives a result like this, which works a lot better. You can see it better if I turn the base image off. This one works by calculating the rate of change in the normal values and the depth of each point after it has been manipulated by the projection of model view matrices. It gives a much cleaner edge with none of the artifacts that you see with the Sobel edge detection like here, because it doesn't care about the colour or the shade, so it doesn't pick up on that kind of change, just on actual changes in the geometry. After doing this, I decided to add cross-hatching to give a sketch-like effect, and this was the easiest part to do because it worked in a similar method to the cell shading. It took the light intensity, which I'd already calculated previously, but instead of using it as a coordinate in a one-dimensional texture, it worked through a series of if-else statements to select a different two-dimensional texture, each of which had a different intensity of shading on it, and so at each point it would choose the relevant two-dimensional texture, which were created in layers on top of each other so that it would fit together smoothly. And I'm quite happy with that. The textures could be better, but I'm not an artist, and I think that gives a nice effect. The cross-hatching works better in black and white rather than, as you can see, with a texture underneath. It's maybe a bit too busy looking, but for a black and white texture, I think it gives a nice effect. Just to show some of the effects in another model, this is the other model I'm going to show you. I got this free from TurboSquid, where there's lots of free models. I think this especially shows that the cell shading and the normal depth edge detection does give a nice effect. I'm especially happy with the facial effect it gives, and you can also see the cross-hatching applied to this. There were 9 levels of cross-hatching supplied, but I think the intensity doesn't get dark enough to use them all, which could be something to be worked on as a further exercise in a future tutorial. Overall, I'm happy with the way it's turned out. Some of the effects appear quite simple, but some of the code to implement them is quite involved, and I think it's a good tutorial for anyone interested in non-photorealistic rendering. Thank you.